Hello, everyone. In this talk, I'm going to introduce a design methodology that I've developed for building secure Android apps. So we all know that Android apps have become an integral part of our lives. We use them to manage our finances, for communicating with others, and for other security-related things like two-factor authentication. Hence, it's important that developers who build these apps make sure that these apps are secure and do not have vulnerabilities that may cause the harm to the user in any way. But even today, we find that vulnerabilities are often discovered in apps. For example, we found a couple of vulnerabilities in the Google Camera app and the Gmail app that allowed the leakage of information, private information, and it allowed a malicious app to exploit the vulnerabilities and carry out a denial of service attack. A recent study by IBM shows that the average cost of a data breach is quite high, which means that if vulnerabilities are found in apps, they can be quite expensive to fix. So this brings us to this question that how do we secure Android apps? Well, the current prevalent approach is to take a curative approach and detect vulnerabilities in an app after the app has been built. Now, the problem with this is that after an app has been built, and if you discover vulnerabilities, that's going to raise development costs and maintenance costs. So an alternative is to take a more preventive approach and to consider and bake security into the app's design itself. Now, this is not commonly used in app development, which is why this is the focus of my research. So my proposed solution here is to bake security into the storyboarding phase of an app development process. So when an app is developed, it begins with storyboarding, which briefly includes first defining the screens of the app, and then the flow of the app is defined in terms of those screens, and then the designer will go and sort of define how the app will interact with the user and the underlying platform, or other web services or databases, for example. But the problem with this is, in this phase, it is difficult to reason about security properties and what kind of vulnerabilities that may occur, because there is no capability to express security features in an app's storyboard. So the question is, can we extend the traditional features of an app's storyboard in a way that will allow the developer and the designer to collaborate and reason about security in a meaningful way? So it turns out that we can, which is what my methodology is all about, where the developer and the designer will collaborate, and they'll start off with this storyboard, which is no different from what existing storyboards are. And we have sort of extended the traditional storyboard's capability that will allow the developer to specify the security properties of known vulnerabilities that can occur in an app. And then the developer can go and verify those properties in the app's storyboard. If those properties are verified, then it's fine. Otherwise, the developer will be told where to fix them. And once everything is good, the developer can generate code and extend the generated code with business logic as well. So a proof of concept of this methodology has been implemented using Android Jetpack's navigation graphs, which help us build these storyboards. At the back end, there is an Android lint, which sort of analyzes the storyboard to look for violations of security properties based on existing vulnerabilities. And then there's a plugin to generate code from the storyboard. This is available in the Bitbucket repository. It's open source. I encourage you to go and check it out. And if you want, you can also contribute to it. You can contact me if you want to collaborate on this. So there are a few issues with the existing realization we have, is that when the code is generated, the properties that have been verified at the storyboard stage may not be preserved in the generated business logic code because the developer can change it. So we have to think about ways to sort of preserve that, and one way is to use sandboxing techniques. The other thing that I want to do is to integrate this approach with existing cross-platform app design tools like Flutter and also to find out a way to express security properties that are based on privacy policies of apps. So that brings me to the end of this talk. I look forward to interacting with you in the live chat session. Thank you very much.